Professor?
Yes,
I just had a quick question about the topics for the test.
wow. I'm going to repeat it now. Well, I said this many times already. So your test one will be on section 13.1 to 13.3 and also 14.3. Okay. Is that all you need to know? So any more questions about the test?
Yes. On a test day, do we have to open up the Zoom so you can see us writing the test?
Well, it's up to you. This is
Right.
why I did not even answer the question, because this is entirely up to you,
All right.
all right?
Professor,
Yes,
didn't we also learn 14.1?
I
Functions
cover
of-
a little bit of that, okay? But there's not much to be tested. They are about functions, and we are talking about functions all the time. Okay, so all those topics will be tested in section 14.3. All right, so is this. I didn't do much from section 14.1. Okay. All right. Well, I said many times that the test will cover everything done in class. Well, these sections. And what else did I tell you? Well, it will be an open book exam. You can use whatever notes, whatever books. You can even use the internet, okay? But one thing that is strictly forbidden is that you collaborate with your peers, okay? In other words, no human participation, okay? And another thing is that you are not supposed to pose the questions in the tutoring companies for help. That's a very serious offense anyway. Okay. So any further questions about your test? Okay, if not, well, I will write this down anyway. I will write this down and post this in eClass. Okay, about the instructions, about what you should do, what you should not do. Okay. All right. Well, today we are going to start with tangent plane. Okay. This is in section 14.4. All right. So let's suppose that we have a function. A function of two variables. Okay. On a certain subset of the xy plane. Okay. I'm not going to write down the domain because it's not important. Now we are going to look at this graph. So we let S. B is graph. So pictorially, we have a situation like this. So we have the X, Y, Z space. Okay. And then first of all, you are going to draw the domain of the function on the XY plane. And then you look at its graph, and its graph is actually a surface in R3. Okay. So this is the graph. Okay. Now let's take a point in the surface. I am going to call the point capital P. And it has coordinates x naught, y naught, and z naught in R3. And also in S. Okay. So we have something like this. We have the point, which is capital P, and we put it here. And the point P has coordinates x naught, y naught, and z naught. Now, I am going to look at two curves on the surface. A surface actually contains many, many curves. I am going to look at only two of them. So let's say I have a curve going like this. You may say that it's along the x direction. And then you have another one in an arbitrary direction. So we have two curves lying on the surface, okay, passing through the point P. Okay. Now we all know that to every curve we have a tangent or a tangent line, right? So I have a tangent line. And I have another tangent line to the other curve. It's very messy. But anyway, we have two tangent lines. One like this. And the other one like that. Okay? So I say I take two tangent lines, any two. So we take two tangent lines to the surface S. At the point capital P. Now, any two tangent lines would do. And any two tangent lines will do something. What do they do? Anybody?
Two direction vectors of the tangent plane.
Well, they actually span a plane,
Yes.
which we call a tangent plane to the surface S at point P. Okay. So I'm going to say the following thing. So we span a tangent plane. To the surface S. At the point X naught, Y naught, Z naught, or just at P. Okay, this is obvious. Okay. Now, here is something not so obvious. If you take another pair of tangent lines to the surface S at the point P, you get a tangent plane. But is this new tangent plane different from the one that we have just obtained? Could be, right? It's not obvious. But this is actually what mathematics is interesting. In fact, no matter what two tangent lines you pick to the surface S at the point P, you will always obtain the same tangent plane. Okay, I'm not going to show this today, but I will show this later on. Okay, they will become obvious later on. It's not obvious at this point. Okay, so let me put down this fact. Or definition. The tangent plane is not a very difficult fact. I will show this to you later on. The tangent plane to the surface S at the point P is the plane in R0. Okay, so let me try to remove this and draw another figure. So we have the surface S. Okay, like a handkerchief flying in the sky. And then we have the point P. And we have a plane. Or a portion of the plane. Okay. Touching the surface S at the point P. And it's a plane in three-dimensional space. So it's the plane in R3. Okay, that's the plane. And this tangent plane actually contains four tangent lines. To the surface S at the point P. So you use two tangent lines to determine a plane. If you use another pair of tangent lines to the surface to determine another plane, you don't get a new plane. You will get the same plane, which we call the tangent plane, which is indicated like this. Okay? So it's not an obvious fact. Okay? All right. Okay, so much for the definition, so much for the explanation of the terminology and the picture. Now we have a question. We are going to find an equation of the tangent plane to a given surface at a given point. So we are going to find an equation, a standard equation, of course. Find an equation for the tangent plane to the surface S. And this surface S is the graph of the equation. Given by this equation. Okay. And we are also given this point P. So let's say at the point P, with coordinates x naught, y naught, and z naught. Okay, that's the problem. Okay, so let's do it. This course actually is nice in the sense that you are not just doing calculus. You are also seeing something, okay, which is geometry. All right. Let's see how to do it. So, solution. Now, first of all, let me give you the following fact, which you can derive easily. Or you may have seen this in your linear algebra course. So we look at any plane, not just tangent plane. In R3, passing through the point x naught, y naught, and z naught. Okay. Has an equation of the following form, a standard canonical equation. And the equation is easy to remember. Okay. So it's given by A times x minus x naught plus B times y minus y naught let me write it a little bit more to the left. Plus C times Z minus Z naught equals 0. Where A, B, and C are constants, real numbers. constants. Okay. Now, this is actually quite easy to see. This is to the first power, to the first power, to the first power, which means that this is a linear equation. Okay. Well, it's a linear equation in R3. So this is actually an equation of a plane passing through the point x0, y0, and z0. Because when you put x0, y0, z0 for x, y, and z respectively, you will get 0. Okay? All right. And if you want to lie in the plane, you just drop the z curve. Okay? So this is easy geometry. And this is the equation for any plane with no regard to the tangent plane to the given surface. Okay? All right. First of all, I am going to look at the case when C is equal to 0. Okay. And we will try to figure out what's going to happen. So if C is equal to 0, then we are going to get A times x minus x naught plus B times y minus y naught equal to 0. What's the graph of this equation?
Any plane that is vertical to the xy plane, parallel to z axis.
What is it? But what is it? Well, you can solve this for y in terms of x. It's just x and y. So you get a straight line in the xy plane. Right? Okay. Now I can make this. So we get this, which is a line. I mean a straight line in the xy plane. All right. So we are going to get a straight line on the XY plane. So let's say it's something like this. We look at a portion of it, and that's good enough. Okay. Now, we are actually in three-dimensional space. We are in X, Y, and Z space. X and Y are restricted by this straight line on the XY plane. But Z is free. No restriction on Z, right? So this line segment, together with any values of Z, up or down the XY plane, will be permitted. So I only look at positive values of Z. So we get a plane like this. When C is equal to 0, actually the plane can go infinitely down. Okay. Now, what can you conclude? Can this be the tangent plane to the surface as at the point P? Yes or no? It's a vertical plane. And the surface is something like this.
No, since f is a function, so this would imply that f is not a function.
No, this is a plane. But Z is f, x, and y. F at x and y is a surface, right? And we want to find a tangent plane. So a tangent plane cannot be vertical, right?
The line and on the XY plane implies the direction of tangent.
No, but I want a tangent plane.
Yeah, it is not a tangent plane.
It cannot be a
Yeah.
tangent
Yeah,
plane.
it is crossing the plane.
Well, it's a plane, certainly a plane, a vertical.
Yes, vertical plane.
Okay. So we get a vertical plane. Which is not a tangent plane to the surface capital S. this case has to be excluded. So C has to be non-zero. Okay. C has to be non-zero. And then we are going to solve for Z or Z minus Z naught. And it's given by default. So it's minus A over C times X minus X naught minus B over C times Y minus Y naught. Is that correct? Okay, so we get this.
Hello, Professor.
Yeah,
Is this gonna be on the test?
well, if you want me to put this on the test, I can.
No, I was just wondering.
This belongs to section 14.4. That's what I said. All right,
Oh, okay. Thank you.
okay. But this is not difficult, isn't it? Now, I am going to do the following. What is Z? Z is f of xy. So minus Z naught is equal to minus A over C x minus x naught minus B over C times Y minus Y naught. Okay. Now, what am I going to do? I am going to take the partial derivative. You see? Material in section 14.3 also come up in section 14.4. Okay, so sometimes I only cover some sections very superficially because there is not much in it. And James Stewart is very long-winded about certain topics. But the important topics will actually come up in more important context. Now, I am going to take the partial derivative. df dx. Okay. Well, I can evaluate this at x naught, y naught. because we are actually looking at the point x naught, y naught, and z naught. So what is it? When you differentiate, I am going to get minus a over c. Because this is equal to 1. And when I differentiate this with respect to x, what do I get? Anybody?
Do you get 0?
I get 0. So that's basically it. So minus a over c is the first order partial derivative of the function f with respect to x. I don't need this anymore. And similarly, I can take the partial derivative of f with respect to y. And then I can evaluate this at x naught, y naught. Okay. And then I am going to get minus b over c. So finally, I am going to end up with the following equation. Therefore, an equation of the tangent plane so an equation of the tangent plane to the surface S at the point x naught, y naught, and z naught. Is given by this. So I have z minus z naught equal to the partial derivatives of f with respect to x at x naught and y naught times x minus x naught. Very difficult to write here. And then we have the partial derivative with respect to y at x naught and y naught. Times y minus y naught. That's the equation of the tangent plane. Okay? So I will stop here today. So, any questions?
I want to ask a question for why C cannot be 0.
Well, you saw it. When C is equal to 0, you get a vertical plane. And if you have a surface, you have a surface. And then you have a vertical plane. And the vertical plane would intersect the surface. Right? In a curve. It doesn't give you the tangent plane. That's the reason. Can a
Usually
vertical,
yeah.
can a vertical plane be a tangent plane? Well, just take a surface like this. Okay, can it be a tangent plane if the plane is vertical? No. Right? Any further questions? It's very quiet.
Also have a question for why the df over dx for the b over c equals to 0.
I don't understand you. You mean here? The derivative of z naught?
And not this one.
Which one?
Mm,
A over c is a constant.
yeah.
And then when you differentiate x minus x naught with respect to x, what do you get? You get 1. Right?
Yes.
So df dx is 1, is minus a over c.
Yeah.
Okay? And the same for df dy, the same for df dy.
Hi,
Okay?
Dr. Wang.
Yeah.
I'm sorry to make you repeat, but could you explain why, if C is 0, we'll only have a vertical tangent plane one more time?
Well, if C is equal to 0. And you have this equation. And then this is a straight line on the xy plane. You have only x and y, right? So you have a straight line on the xy plane. Let's say something like this. Well, actually, it's infinitely long, but we look at a segment of it. Now, what about Z? This is XYZ space. Z can be anything. Okay, well, anything means any values here. All right, you cannot take it like this, that's the X direction. You cannot take it like this, that's the Y direction. You cannot take it like this, it's an oblique direction. So you have to take Z vertically, right? So if you take Z vertically, building on this line segment, you are going to get a plane like this. That's a vertical plane, right? It's oblique,
Okay, thank you.
okay? It's not parallel to the YZ plane, it's not parallel to the XZ plane, it's in an oblique position. Okay,
Sure.
yeah, go ahead.
Just a quick question. So for the final answer, do I have always to leave the derivative f over x, x not comma y not, x minus x not, or I can just write it?
You are talking too fast, I cannot follow you. So can you repeat the question?
Sure, no problem. So for the final answer, like a equation of a tangent plane,
Yeah,
I have to write the derivative f.
no, you don't have to write it like this. In numerical examples, they all turn out to be numbers.
Oh,
Okay?
so yep, got it. Thank you, sir.
Yeah, but this is the formal derivation, okay?
I
The
see.
formal derivation of the equation of the tangent plane.
Got it. Thank you, sir.
Okay, good. Okay, so maybe we should stop here today. We still have one more class on Wednesday before your test. All right? Okay. So see you on Wednesday.
Bye, sir.
Now, sometimes I cannot answer you emails in the morning because I have to go back to campus to teach. And then once I finish teaching, I have to come back to work on this class. So usually on Monday, Wednesday, Friday, I cannot answer you email until the afternoon. Okay. Actually, I try my very best to answer all emails anyway. Okay. Okay, then see you on Wednesday. Bye-bye.